Hello everyone, I am Mr. Tor, and now we will talking about differentiation. In the opposite figure, you have x-axis and y-axis and the curve f of x. And the x is changed from x1 to x1 plus h. So, you have 2 points at x equal x1, point C, so the point C will be x1 and f of x1. And the second point D on the line on the curve will be x1 plus h and f of x1 plus h. The straight line passing through C and D is called the secant of the curve. To find the slope of the secant, you will find f of x1 plus h minus f of x1 over x1 plus h minus x1 will be h. So the slope of the secant will be the average rate of change as we studied in the last lesson. So if you take h, limit h approaches to 0, as h approaches to 0, the function will be so the slope of the secant of the straight line CD is tan angle u, angle with the positive direction of x-axis, this angle, f of x1 plus h minus f of x1 over h, and this is called average rate of change function. To find the tangent at point C, take the limit h tends to 0, take the limit h tends to 0, f of x1 plus h minus f of x1 all over h, and which is called tan theta, and the slope of the tangent at point C. So the slope of the tangent of the curve of the function f, where y equal f of x at point x1 and f of x1 equal the rate of change in f when x equal x1. So our lesson about differentiation. So the slope of the straight line, the slope of tangent, x-axis and y-axis, and the curve like this. And this curve like this. So the tangent at point C, like this point, we can write that the rate of change equal tan theta, and this is theta, equal limit h approaches to 0, f of x1 plus h minus f of x1 all over h, and the rate of change called first derivative and dy by dx or y dash or f of dash of x or tan theta, where theta is angle with positive direction of x-axis, or slope of tangent to the curve. Let's see an examples on the derivative. Find the slope of the tangent to the curve of the function f, where f of x equal x power 3 minus 4 at the point a 1 and negative 3. Then find the measure of the positive angle which the tangent make with the positive direction of x-axis. So I will find the slope of tangent which equal the rate of change. So dy by dx equal limit h approaches to 0 f of 1 plus h minus f of 1 all over h. So it will be limit h approaches to 0 f of 1 plus h will be 1 plus h power 3 minus 4 minus 1 power 3 minus 4 all over h. So limit h approaches to 0 1 plus h power 3 negative 4 cancelled with negative 4 1 power 3 equal minus 1 power 3 all over h by using theorem 4 on the limit. So it's equal to the power 3 times 1 power 3 minus 1 which equal to 3. So the slope of the tangent equals to 3. So the angle, so tan theta equals to 3. To find the angle, we shift tan the angle theta will be 71 degree 33 minutes and 54 seconds. Another example. If f of x equals 3x power 2 plus 4x plus 7, find the derivative of the function f using the definition of derivative. The definition of derivative dy by dx or f dash equal limit h approaches to 0 f of x plus h minus f of x over h. So I will use the definition f dash of x equal limit h approaches to 0 f of x1 plus h minus f of x1 all over h. So it will be limit h approaches to 0 f of x1 plus h f of x1 plus h equal 3x1 plus h power 2 plus 4 times x1 plus h plus 7 all minus 3x1 power 2 plus 4x1 plus 7 all over h. So limit h approaches to 0, x1 plus h power 2, I will expand the power. So x1 power 2, it will be x1 power 2 plus 2x1h plus h power 2, all times 3, so it will be 3x1 power 2 plus 6x1 times h plus 3h power 2 plus 4x1 plus 4h plus 7 minus 3x1 power 2 minus 4x1 minus 7. So all over h. Simplify the numerator, 3x1 power 2 cancelled with 3x1 power 2, 7 cancelled with 7, and 4x1 will be cancelled with negative 4x1. So the remainder on the numerator, 6x1h plus 3h power 2 plus 4h. Take h common factor. So limit h approaches to 0, h common factor, so it will be 6x1 plus 3h plus 4 all over h, cancel h with h. So h approaches to 0 by substitution about h equals 0, so it will be 6x1 plus 4. This is the first derivative. Find the slope of the tangent at the point negative 1 and 6. So the slope of the tangent x equal to negative 1 by substitution. So f dash of negative 1 equal 6 times negative 1 plus 4 equals to negative 2. The second one proves that f of x equal x power 2 minus x plus 1 is differentiable at x equal 1 by definition. To prove that the function f of x equal x power 2 minus x plus 1 is differentiable, you must find the value of the limit. So dy by dx, or f dash of x, equals limit h approaches to 0, f of x 1 plus h will be 1 plus h minus f of 1 all over h, all over h. So limit h approaches to 0, 1 plus h power 2 minus 1 plus h plus 1 all minus 1 power 2 minus 1 plus 1 all over h. So will be limit h approaches to 0, 1 plus h power 2 equal 1 plus 2h plus h power 2 minus 1 minus h plus 1 minus 1 all over h. 1 cancelled with 1 and the negative 1 cancelled with 1. So take h common factor, or 2h minus h will be h, so limit h approaches to 0, 2h minus h will be h plus h power 2 all over h. So limit h approaches to 0, h divided h equal 1 plus h power 2 divided h equal h. So h equals 0, the result will be 1. So the function differentiable at x equal 1 and the slope of the tangent equal to 1. Thank you very much and see you later.